Hey everybody, I'm Danny Hermes. Welcome to this week's edition of App Engine Google Developers Live. I'm here to talk to you about endpoints with my colleague Dan Holyvote.
Hi. So today we're going to talk to you about a new feature that has just reached the experimental phase in the App Engine SDK.
Literally just reached.
Literally, hours before this. And the basic idea behind this feature, called Google Cloud Endpoints, is that it's a really easy way for you to make APIs hosted on App Engine that you can consume within Android, iOS applications, and JavaScript.
Why would you want to do that?
Well, so what we've discovered with App Engine is actually it's a really great place to host backends for mobile applications. So the big pitch behind this feature is that you can generate these APIs. We provide really great tooling around them so that you can get great statically typed client libraries for Java and Objective-C. And then if you're building a mobile application for the web as well, you also get this great JavaScript library.
Totally. All right. Well, I'm going to get started now. From here forward, I'm going to be teaching you guys about endpoints through live coding. I'm going to be programming in the Python SDK. The Python App Engine SDK version 1.7.5 just became available today, and we had a blog post announcing that. So let's get started. So here I am, my application. The very first thing I need an app.yaml file. So I'm not going to actually deploy anything today. We're just going to be working in the SDK, but everything that works in the SDK is also going to be working in production, and then some. So my app ID, I'll just put your app ID, or, well, endpoints app, just to be relevant. We need a version, we need a runtime. I'm going to use Python 2.7. Is it thread safe? Thread AF. Thread safe, true, and I can't remember. I got to cheat. API version, there we go, to actually tell us which version of the runtime we're using. And I'll just continue cheating. We're going to simply spin up a backend, and we're going to use some of the testing tools provided with the SDK and some of the rest of Google's API tooling external to App Engine to actually test this backend. We're not going to build a front end. We're not going to build JavaScript, iOS, or Android clients. But we will do this in the future. We just want to show you quickly, in a few minutes, how you can get up and running with your first backend. So what I have here is I'm mapping the path _AH/SPI, and then I have the wildcard .glob or .asterisk after that, meaning everything in that path will be handled by my app main.application. And this is a special internal path used to actually talk to Google's API infrastructure. In this case, it's not directly talking to our API infrastructure because it's running locally, but it talks to an approximation of that. But in production, it actually talks to Google's API infrastructure directly. And I'll talk a bit more about what that exchange looks like when we write some code. Okay, so now we need our main.py file that's going to hold application. So I'll start up main.py. I'm going to have to cheat a bit on this, but I'm going to go until I can't remember anything. So the first thing we need to do, we need to actually import endpoints. So as of today, and actually as of the last release, but it wasn't fully working, we have App Engine in google.appengine.ext, and we can just import endpoints from there. And that provides us with most of the things we need to actually use endpoints. There's one other import that's pretty important, and that's a library called ProtoRPC. So ProtoRPC, I'm going to take a break and talk about it. So we want the messages module within ProtoRPC, but what ProtoRPC is, it's a library that is an experimental library as part of App Engine. It was released several months ago, maybe a year ago at this point. I'm not exactly sure the full timeline. And it allows essentially a native Python object that can talk protocol buffers. And this is pretty important, especially when you're talking Google's internal infrastructure, to actually send messages around and have strongly typed messages out of, sending from one arbitrary runtime to another. And it's a way for large services that aren't necessarily the same to be able to talk to each other, right? And so since, as I mentioned before, we have this path _AHSPI to actually talk to Google's infrastructure, we need to provide a mechanism to actually make this conversation happen. And we use ProtoRPC to create protocol buffers and actually speak JSON RPC. I'm not going to go much further than that. But essentially, it's a way to have strongly typed messages that you can use to actually talk to other parts of the infrastructure. Cool. So before we actually design our application, I want to talk about what it is. So what I'm going to do is make a simple API that allows you to insert tasks and to retrieve tasks. Now, I know what you're probably thinking. Google has a tasks API, and we saw Dan talk about it not too long ago on GDL. That's okay. I'm not proposing that you build a tasks API, but it's a simple enough concept for everyone to understand, and I just want to show you a proof of concept, right? But don't build a production tasks API because you can already use existing ones, right? All right. With that in mind, we need a way to represent our tasks using ProtoRPC, right? So what kind of fields would you like in a task object?
Maybe a name might be good.
Okay.
Someone who owns the task.
Okay.
How about a due date? Can you do that one?
Yeah. Dan has made this difficult. So
let's just start with a name and an owner. Can we do that one first?
Yeah. So the reason the due date is difficult, it's just difficult to do right. We could fake it with a string, but this is going to leave the scope of this talk pretty quickly if we do that. So we're going to have the name, which is a string, and the owner, again, just a string. We're not going to use any auth to be able to find out emails or names of people inserting things. Brain fart. So what we have here, we have a class called task, which is going to represent our data, and it's an instance, or excuse me, it's a subclass of messages.message. And messages is that module from ProtoRPC, and this is a ProtoRPC message definition to actually talk protocol buffers, right? And so we give it two fields. The first field is name, and this is going to be an instance of messages.string field. And we have these generic field classes, which actually allow us to create classes within our message classes like task here. And we actually have to give them numbers to have some sort of ordering within our protocol buffer definition. And for owner, I'm going to use the same thing, except I'm going to give it the index of 2 instead of 1. Now, should either of these be required?
The name should probably be required.
Name should probably be required. So we can add required equals true to the string field that represents name, and this will actually be enforced when the objects are created and passed around and do other things. Okay? Now, I'll just wrap up on getting our data and actually go and build the API. So I need another class. I need a class to represent lists of tasks, because we're going to do queries that are going to return lists, right? So it's going to be the same type of thing. I'm not asking for Dan's input on here. We're just going to have one field, items, and that items field is just going to be a list. So instead of task, we'll call it task list. Instead of name, we'll call the field items. It's not going to be a string field. It's actually going to be a message field. So this message field holds more messages, right? And like we saw with string field, the very first argument to the constructor is the index. For message fields, it's actually the class of the message. So we need a list of tasks in our task list. So our message field is going to have task as the first argument, the index 1 as the second, and instead of required, we're going to have repeated equals true, because we'd like multiple tasks within this task list. Okay, great. So now we're representing our data. Now we need to actually build our API. And again, building the API, we're going to use the mechanics provided by ProtoRPC. I'm going to add from ProtoRPC import remote here. Remote is another module provided by ProtoRPC, which allows for actually standing up a ProtoRPC client which can communicate externally, right? These are just ways to represent data, but remote actually allows us to make a client, and as we'll see, it allows us to make a WSGI handler, which is what's going to end up in application and be able to talk to the rest of the pieces. Okay, cool. So we'll start off with task API is the silly name. And it's going to be a subclass of remote.service. And remote.service is is that class that I was talking about that actually allows for things like communication and WSGI handler, etc. Okay, great. So we got nothing in there. We're going to need two things, right? We're going to need to insert and we're going to need to list. So I'm going to create two dummy methods that do nothing for now. Insert is going to start us off. It's going to be an instance method, meaning we have self on it, and it's going to take a request. So the request is going to come in, and we're going to insert something based on what's in the request. More details on that in a bit. And then list is going to be something similar. Okay? So, I'm gonna call it list tasks. I could use list, but as we just saw in Emacs there, it recognizes it as one of those reserves words in Python that you probably just shouldn't use. And I'm also, to be extra clear, instead of insert, I'm going to say insert task. Just to be, good programming citizens. Okay, great. Actually, let me hold off. Well, this is fine for now. It won't actually matter. So in order to make this talk to endpoints, we need to add some decorators. We need to annotate these a bit, get some metadata, and actually figure out what this actually does, how it relates to task list and task, which we just defined, and a few other bits and pieces, right? So now I'm actually going to use this from google.appengine.ext import endpoints import. Okay? So what do you think the first thing I should add is, Dan?
I don't know. Why don't you show us?
All right, fine. Dan doesn't like this. Dan wants to talk about Java endpoints, and I'm sure he will at some point.
I just don't want to make it too difficult for doing this on the
I
air.
see. He thought he made it hard for me before. Well, I kind of like it when I screw up on camera because it makes it more interesting for you guys and lets you see how we debug things and how we actually program and figure things out. But Dan doesn't like it.
I want due dates in the text.
Yes. So I'm going to first decorate the service. So this task API service, it needs to know its name. For those of you who have used Google APIs before, you'll know for the majority of our APIs, our discovery-based APIs, they're really identified by a name and a version. So like YouTube has 3 APIs. The first 2 aren't discovery-based, but the third one is. So if you have YouTube v3, you can identify the YouTube API, and so similarly for many of our other APIs. So we give it a name. We'll just call it tasks. Very creative there. We'll give it a version, v1, and just for fun, I'm going to give it a description so that if any human was actually consuming what's called the discovery document for this application, I've already mentioned discovery a bit, they could see a nice description of what this is. So the human readable description will just say task API. Well, API for task management. It's not literally for task management because we're not going to allow you to delete and check off and do these other things. But
or have due dates.
We easily could. Or have due dates. Who needs a due date? Okay, great. So so now I actually need to do a similar thing for the methods. In the same way that the API itself needs to know who it is, each individual method needs to know who it is relative to the application. Okay? So I'm going to do something similar, but instead of endpoints.api, I'm going to use the endpoints.method decorator. Now, if these aren't intuitive names, I don't know what else we should have used. I think they're pretty intuitive names. So we need to give this a few things, but most importantly, we need to tell it what kind of data it can expect to receive and what kind of data it can expect to spit back out, right? So on the way in, we're going to take a task, and on the way out, we're going to spit a task out, right? It's not magic. Now, what we do with that task once it reaches our API is up to us, right? But this is why we actually made those protocol buffer definitions so that we can actually figure out what's supposed to go in here, right? Great. So we've got that. This is the part where I may need to cheat. So I'm fairly certain I can remember all this, but I guess we'll try to run it and see if it breaks. That's the funnest thing. Okay. So to give the method a name, I'm actually going to use task.insert. I probably don't need to use the dot, but I'm not 100% sure if this will. So traditionally with Google APIs, for those who are familiar, we have an API, and then there's sub-resources within the API. So for people familiar with the Drive API, for example, they have an about sub-resource, and you can get sort of information about the individual user as it relates to Drive. And they also have a files sub-resource. So if you want to get a list of files or get metadata about an individual file, delete a file, change a title of a document, you name it, they have a sub-resource. So in this, we're thinking of task as our sub-resource and insert as the actual method name for this. In addition, we actually need to tell the API the path that it can expect the request to come in on. So here for path, I used the string path. I didn't mean to. That's because I was talking and typing. We're just going to use the string task. Okay. So that means when they come through, in this case, it's going to be _AH/API/task. Well, actually, that's not even true. There's
API
more things.
name.
Yeah,
version.
/API name /version/task. There we go. They will actually hit our API, but you won't necessarily need to worry about all this, as we'll show in a bit, because the rich amount of client libraries that have been built up by us and our colleagues for people who are already using Google APIs. Within App Engine, we don't necessarily talk about other Google APIs as much, but other teams that you may have seen on GDL or through various other things are very strongly about building up this ecosystem, making these libraries work, and doing great things like that.
Yeah, if you build an API using endpoints, the end result will look a lot like Google APIs that were authored by Google.
Yes.
And the way that you consume them within your applications will feel very similar, if not identical, to the way that you'd use other Google APIs.
Definitely. I believe I have everything I need. Actually, no, I don't quite. So I'm also going to specify an HTTP method. So I want to specify it as post, since we're inserting something. That's the RESTful concept. Now, I actually happen to know this. Post is the default for this this keyword argument, but I wanted to actually have it in there to indicate it to you guys. Okay, so enough talking. I'm just going to actually wrap up on this particular method, and we'll actually see if we can get it to work. So instead of actually saving the request or doing anything with it, we're just going to return it back to the user and see what happens. So before I can run it, I actually need an application. I believe I can just use endpoints.api server and give it a list of my APIs. So I haven't cheated yet, have I? I kind of cheated. API
really.
version on
Not really.
YAML. Okay. So sorry. So what I've done here, in addition to endpoints.api and endpoints.method, these decorators that we've used, we also have endpoints.api server, and what that does, it takes a list of APIs that you've defined. So in this case, we've only defined task API, and it will actually create up, it will spin up a server to serve the request and actually make the API work. So enough coding. Let's actually see if it works or not. Dun, dun, dun.
Place your bets.
Place your bets. So I'm here in the Google App Engine launcher. I haven't figured out how to increase the font size on this ever, but I've got my app running, and I'll head over to Chrome just to make sure it's running. So I went to the admin console for the app, and again, it's running. It's good. And we want to test the actual Explorer for the application, and so it's very simple. There's a protected path under _AH, which is, as people familiar with App Engine know, full of protected paths. So if we go to localhost 8080, which is the local name for the app that I'm running, _AH/API/Explorer. Now this is the moment of truth. No problems. No problems yet. So what happened was, for people who can't see, the font size in the URL bar is fairly small. But what it's done is it's redirected us to the Google APIs Explorer, which lives on at developers.google.com/APIs-Explorer. And it's passed the query parameter base equals with the actual place where my location, or excuse me, my application lives. And this base is localhost 8080/_AH/API. And this is essentially a root for all operations. Dan mentioned that full path is going to be this root plus your API name plus your API version plus whatever your path is, right? So this is how we're actually calling it, and everything gets constructed based on that root and other pieces of data about your application. So it's loaded up the full list of APIs that we have available. Just one, right? When I constructed my endpoints.api server, I just passed it one thing. That's all we expected. We see the version v1 that we created. Just to prove I'm not lying, let's go change it and refresh this. Version v-GDL. Loading. Oh, wonderful. No issues so far. I don't. Maybe it's less fun if there's no errors. Maybe I should have had more screw-ups.
Maybe something's secretly going to go wrong.
Yeah. We'll see. And so we see the name we gave for the API is tasks, right? And then this human-readable description API for task management also there for your use when you're debugging and for end users if you go that route. So when I click into this API, we get a list of the methods that we have available to us. So as I mentioned, we have the task.insert method, and the way it's interpreted by the APIs Explorer and by the general infrastructure that is used to create these APIs, tasks is the API name, task is the resource, and insert is the method, okay? So I'm gonna do something which I hope breaks. I'm going to try to call this insert method with absolutely nothing in there. So we have this little box with request body. This is, again, part of the phenomenal tooling we have already available for you when you're working with Google APIs, can automatically be used with your API for testing out. This request body knows the fields that it has available to it. From the discovery document for my application, we actually see name and owner here, which are the fields that we added, right? We made name a required property. So I'm going to submit a request without name and see what happens. I'm going to guess that, interesting. Well, let's see what happens. So we got a 400, wonderful. And that 400 means it didn't work, and the error is essentially that there was an error parsing the ProtoRPC request. So when ProtoRPC got the empty body, it tried to turn the empty body into an instance of this task message class that we define, and it said, no, we're missing a required field name. Sorry, we're missing the required field name.
Does it say that in there?
It does.
Excellent.
Message task is missing required field name. That one is a bit ambiguous if you call your field name, it turns out, right? So let's just give it name. Go to sleep. That's a good name for a task, right? Okay, wonderful. So so far no bugs that I know of. So we have a 200. Okay. And the response is exactly what was in the request. Okay. So now let's make the API do something at all, right? So we have this request object that comes in. I'm just going to do like a repeat. So for the name. So if the name is A, it's going to turn it into AA, right? So I think times equals will work for this. Yes?
I think you're right.
I'm just going to try it. All right. So I'm calling request.name times equals true. As far as I know, it'll take the string that's in request.name and replace it with string concatenated on top of itself. Let's just see. Oh, I closed. Didn't mean to close it. Okay. Great. Go to sleep, go to sleep. Obviously, we don't want to do that. So before I actually go into ways that you can store the data, interact with the data, otherwise, I'm going to move on and implement the list method. I do want to note, I don't know off the top of my head the path to the discovery document, but I want to show you guys this before I actually before I move on to the list method. So we've mentioned this a lot. So this is actually creating a discovery-based API for you. So that's the reason this API's Explorer works, and the reason our Android and Objective-C clients just work for you because they already know how to take a discovery document, consume it, and turn it into the thing it needs to be turned into. So I believe this is the link. Let's see. Fingers crossed. Not found. I might give up.
You could show a public one as well if you don't want to show your local one.
Yeah, that's not as fun. Yeah, it was the wrong link. I just suck. No, it was the right one. Suck again. Oh, no, you know what? I went too far back in the history. It's V1, and we changed V1 to VGDL for your benefit. There we go. It really doesn't exist. But VGDL does exist. There we go. Our first 404.
Excellent.
We got a 404. Great. So here's the discovery document. Now, it's just a JSON document, but it's fairly long, and it describes very nice things that intelligent clients can actually use. So we've got simple things, right? We've got the name and the version, tasks, VGDL, the description. But very quickly, we get some more useful things. So we have here schemas. Schemas actually describe the data so that things like what we saw in the client, those drop-downs that know what it's supposed to actually be sending, can actually create these drop-downs, right? And it's the same thing when you have, this is running in JavaScript, so it's just kind of like, whatever you want to do it. But in strongly typed languages like Java and Objective-C, on Android, we're actually able to use these schemas and create strongly typed classes that you can call. You don't have to write any of the code to interact with these things, right? And of course, we also have resources. And resources gives us a way to actually figure out what the API can do. So we have this resource task, which I created, as I mentioned, right? And it has a bunch of methods. And well, for now, it just has one method, right? But it will list more, and you can get listings of other sub-resources. OK, great. So I just looked at the clock. I'm going to implement list tasks. Actually, first I need to store them.
Yes.
Oh, OK. So I'm going to do it. It'll be OK. So I'm going to import NDB. We're gonna come up with a simple model to actually store the task itself. And we're going to use NDB queries to populate our list.
And
right?
why are we going to use NDB?
We're going to use NDB because DB is not as good. There are two data store APIs in Python. One's called DB, one's called NDB. The feature set of DB is completely contained in the feature set of NDB. And without really changing any code at all, by switching to NDB, you get caching for free. I've said this a lot on GDL, but
well,
I'll say it some more.
It's good
and
to
I'll
repeat
continue to say it some more. So I'm just going to copy this model pretty much verbatim. This message class. I'm gonna create an NDB model, and I'll just call it task model. So it's going to be a subclass of ndb.model, and instead of messages.string field, I'm going to use ndb.string property. For those paying extra close attention, you may have noticed that I initially typed string property instead of string field. Unlike with protocol buffer definitions, here we don't actually need the index 1 and 2. So I'm going to use the same field names, name and owner, and I'm going to make name required again. So all I'm going to do with this task model is turn the request into an instance of task model. So I'm going to set name equal to the name from the request. I'm going to set owner equal to the owner from the request. Oops. Request.owner. I have no sense for how close this is to 80 characters because the font is so big. And I'm just going to put that in the data store. So in this initial call to task model, I'm creating a model instance. And on the instance, there's a put method, which just saves the object in the data store. So here it's going to come in handy that we have the data store viewer open in the admin console. OK, great. So let me do a few of these. So we've done this for go to sleep. Maybe we'll have wake up. Who should wake up? Definitely not me. Can't say Dan H because that's both of us. Did that execute? Oh, there we go. OK. And so let me refresh this guy. If we go to the data store, we can actually see the models that we've inserted. And if we were to play around more with it, we could get more of them, right? But we just want to do a query and then peace out. So let's actually implement this other method. So in the query case, we actually don't need an input request. So actually, no, we're not going to use it. So there's one, I can't remember what it's called. I think it's ProtoRPC message types, and it's got a mess. Let's see. I believe in ProtoRPC.message types, there is a class called void message, and void message is for things like a simple query like this, where you don't actually want to send any information in the query, you just want information out in the response. Now, in reality, if you're doing queries, you'd like to allow paging, so you'd want you'd want somebody to give a token for paging. You'd want to allow them to limit the size, right? And there's probably tons of other things you'd want to allow. Filters, like etc. Right? But for this one, we're just going to use void message. And on the way out, we're going to have a task list. Let me clean up. Where is this? There we go. OK. We're going to call this task.list. We'll leave it in the task resource. Doesn't really matter. We could put in another resource. It's doing the same things. And instead of using the path task, we're using the path tasks. Also, instead of post, we're using get. So actually, since we're using different HTTP verbs, we could actually use the same path task for both. But like, it's not very intuitive to have tasks if you're returning a list of tasks, right?
Yes.
So it actually turns out that request won't be used because it's going to be an instance of void message. We're going to have to use NDB here to actually query our task model. Okay, so this is about endpoints, not NDB. So if there are NDB things that are not familiar, feel free to ask them on our moderator queue or put them other places. But for now, I'm just going to do it. So there's a query method on the model itself, and I can just loop through all the results in the query. So for task in task model.query, I'm going to save an instance of the ProtoRPC task model corresponding to what came from the data store. Now we can see you'd probably like some nice methods to go back and forth, and we're actually going to talk about this a bit in next week. But for now, we're just going to do it the old-fashioned way. So using this task, we're going to append an instance of task. Now, task is the ProtoRPC class, not the NDB class. But we're going to actually use the same values from the task that we got from the data store. So task, we're going to pass name task.name, and owner is going to be task.owner. OK. And then we're going to return an instance of tasks list. And for items, we're just going to give it our list of tasks.
Sounds good.
Fingers crossed?
Fingers crossed.
Let's see it. So I'm going to reload the page, which has all my methods that I can use. Nothing broke yet. Gonna go into the list, the list method now to actually execute. And we got a 200. OK.
Is the content there?
The content is there. It is not pretty printed. I actually know why it's not pretty printed. We should do this. JSON.dumps, if you include indent equals 2, it'll make it pretty. This isn't so pretty. But what it has items with a list with 2 elements. The first is the task go to sleep with no owner. And the second, the less lazy one of us, Dan, it's actually not true in real life, owns the task wake up. And you could, of course, go ahead, insert something else, like, I don't know, record this.
Answer my email. Schedule meetings.
Mystery GDL producer. OK, and then we go back we ask for a list, and hopefully the task record this for mystery GL producers in there. Yeah, there we go. So I'm going to wrap this up. We're going to be doing a fair amount more of production content, some live, some not live for endpoints. But next week, I'm going to be talking about another library that you can use that I personally wrote called Endpoints Proto Data Store. And from here, we're going to go to the moderator and try to answer as many questions as makes sense.
Yes. Let's also put in a plug for the public documentation we have. If you go to developers.google.com/appengine, we have nice Java and Python documentation there for endpoints. If you follow our repositories on GitHub, Google Cloud Platform, we also have examples of the Java and Python backend in a simple tic-tac-toe application. And we have example clients for tic-tac-toe for JavaScript, iOS, and Android as well. So those are pretty good places to get started if you want to see a little bit more about this.
Totally.
All right, so let's go to the questions. Let me refresh these here. All right, we've got 5. Excellent. So first one, how can I use Google Endpoints code generation via command line tools like Maven or Gradle so that release engineers and build tools like Jenkins can build and test endpoints from annotated source code? So I think if I understand this question correctly, it's asking how you would integrate some of the client library generation, maybe discovery doc generation that we do as part of the SDK into, like the release managements that you might want to do with Maven. So I believe, and I'm not an expert with Maven by any stretch of the imagination, but I believe you can run command line scripts from within a Maven command, right? So all the things that you were showing, if I were to actually go and generate an Android client library, an Objective-C client library, I just run a command on the command line. We have equivalents in both Python and Java for that. I could create a rule that says, build my backend. When I'm done, generate this command that will run based off the jars that I've generated. Give me my output client library.
Totally.
So it will totally work. Maybe we need some examples on this. Not exactly sure. Maybe that's enough for people to figure it out. We'll see, I guess.
In the Python case, there's endpoints.cfg.py,
Right.
and it's in our wonderful documentation, which launched today. For those who want to use it with integration and testing, it's the source is open, so you can just see the methods which actually correspond to the argument parser and actually call those directly, or somehow script calling it yourself.
Right, and we have a .sh equivalent for the Java side too.
Is it endpointscfg.sh or
I believe
endpoints.sh?
I believe it's endpointscfg.sh.
Good enough. So we have endpointscfg.sh and .py for each of your poisons.
Yes, for people who like to use Eclipse, I'm sure there are some of you, we also have an excellent integration in the Google plugin for Eclipse that lets you really easily generate client libraries without having to touch the command line at all. So if you're using Eclipse, definitely do that. It's way easier. But if you're not an Eclipse person or you prefer the command line, we have great tools for this stuff. All right, next question. Are endpoints allowed to return binary content, i.e. a blob store item, or are they limited to text?
So we only use string here just for ease, right? There are many types supported, and we're working on getting support for all of them. We currently support strings. In Python, we support bytes, but what happens on the client, you're going to have a URL safe base64 version, and that's what gets passed to the server, and the server decides whether or not those bytes are good or not, whether or not it's safe. Base64, and we support integers, both base 32 and base 64, 32-bit and 64-bit, and we support booleans. We support both floats and doubles. You name it, we support it, and we're working on getting full support within endpoints for this to actually talk to Google's API infrastructure.
Right, and in both the Python and Java case, you can also nest classes inside each other. So if you want a more complex hierarchy of things, you can do that.
As we saw in task list, right?
Right.
Well, we had a message field which referenced, the task message class, and you can, totals all the way down. You can recurse all you like.
Yes, exactly. All right, next question. If my JavaScript client code is running within the same app ID, defining the endpoints and using App Engine's user service, are we automatically authenticated to make requests, or do we need to do the OAuth process anyway?
You are not automatically authenticated. So the way the request comes through your API, it comes through Google's API infrastructure first, rather than to your application directly. So this note about same application isn't necessarily same application, right? The sweet spot there isn't necessarily your web app. It's your web app and your mobile apps, right? So no, the cookie that you have in the browser does not actually come through with the request. So you would need to go through the OAuth dance too. But to have sort of a unified experience with the way you're treating users, it makes as much sense to use OAuth in the browser as it does to use cookies. And we'll be talking more about auth at later dates. But
Yes.
We've tried to make it as easy as possible for launch.
Yes.
But
And
auth is always hard, right?
yeah, as someone that has spent a very large amount of time dealing with OAuth 1 and 2, I can say that this is actually, in my opinion, a relatively amazingly simple experience.
Yes.
So
Yes.
we're looking forward to showing you more about this.
Click a few buttons, cross your fingers, right?
Yeah.
I could do auth right now if you want.
Let's save it. Let's save it. Let's save it. All right, next question. I'd like to know if Unity endpoint is in your roadmap in the short time. Looks like in the short term.
What is Unity endpoint?
I'm not sure, but that suggests to me that it's not in our short-term roadmap.
Probably.
We can find out. We can reply to the question in moderator.
Okay. I'm going to Google it.
All right, sounds good. Yeah, that may be a game framework.
Unity is a game framework, but the word Unity is pretty generic.
Universal.
I don't know. We'll have to come back on that.
We'll come back to that one. All right. And the last question has actually been downvoted heavily.
Uh-oh.
It's sort of unrelated, I think.
Okay. We could just
about
stop.
Excel and FileMaker. So
Okay.
let's just leave that one.
Good deal.
I think we're done.
All right. Well, thanks everybody. Join us again here, same time next week. I'm going to be talking again about Python endpoints, but a library called Endpoints Proto Data Store. And we will be announcing on the Google Cloud Platform developers page, as well as many other social media channels, the other times that we'll be talking.
Great. Sounds good. Thank you.
All right.